Alright, so this is question 4 of the Week 2 Math Counts handout, and it says semicircle P has a radius of 5 centimeters, and then circle Q, which you can see in the picture, that's the largest possible circle that can be inscribed in semicircle P. What is the combined area of the shaded regions that are in the interior of semicircle P, but then they're exterior to circle Q, and then express your answer as a common fraction in terms of pi. So if you look at those shaded regions, the first thing I'm going to point out is we do not have a formula for those specific regions. So we're going to have to figure out how to find the area a different way. Well, if you notice, we're trying to find those shaded regions. If we want to find the area of those, well, that's the, remember, interior of semicircle P, but exterior of semicircle Q. So we could just find the area of semicircle P and then subtract the area of semicircle Q. That's what this whole thing, right? The whole area of semicircle P is all of this, and then all we're doing is just being like, nope, actually we're cutting out this circle Q out of it. So we're trying to find our final area as the area of semicircle P minus the area of circle Q. So let's find the areas of both of those shapes. So the area of a semicircle, right, that's going to be half of the area of a circle. So pi r squared over 2. And the area of a circle, of course, is just pi r squared. And so let me just call this radius the radius of P, and this is the radius of Q. So the radius of P, it tells us that's just 5 centimeters. So this area is going to be pi times 5 squared over 2, which is 25 pi over 2. But what about the radius of circle Q? Well, it doesn't tell us this specifically, but what we do know is that this right here is the radius of P, because remember, the radius goes around, it goes down. This is also the radius of P. So if this entire thing, the diameter of circle Q, is the radius of P, that means the diameter of circle Q is 5 centimeters, which means the radius of circle Q is half of that. It's 5½ centimeters. So we can plug that in, and we get this. The area of circle Q is pi times 5½ squared, which is 25 pi over 4. And remember, we're subtracting AP minus AQ, so that's going to be equal to 25 pi over 2, which is equal to 50 pi over 4, minus 25 pi over 4. So our final area of those shaded regions is going to be 25 pi over 4.